Quantum reality behaves very peculiarly. It actually behaves retrocausally.
Retrocausality is the idea that the arrow of time is not a one-way street, and that what happens now can influence what happened in the past. It all started with two papers in 1964. You might have heard of one of them. John Bell, working by himself at CERN, showed that the universe cannot be both local and real. His paper led to a Nobel Prize, but more importantly, it sparked decades of experiments that changed how we understand the nature of reality. The other paper was published the same year in the same journal by three physicists at Yeshiva University in New York. It appeared in Physical Review, a highly respected physics journal. They showed that the apparent arrow of time in quantum mechanics, the idea that cause always comes before effect, and the past determines the future, is not actually part of quantum world. Instead, their findings revealed that the fundamental laws governing subatomic particles are entirely time-symmetric. The equations work the same way, whether you go forward or backward in time. The past can shape the future, and the future can shape the past. The most famous evidence for the retrocausality comes from the delayed choice experiment.
So what they did in this experiment, basically what they did was they took a laser beam, all right, and they put it through a beam splitter. So you have the same beam, but then it's split into two. Now then what they did was they weakly measured the photons in both beams, all right? And then they subjected one of the beams to a strong measurement, if you want to put it that way. And what they discovered was that back in time when they were weakly measured, the photons that got the later strong measurement had been amplified significantly. So that later measurement amplified the photons in their past, causes that events in the future, at time point B, things at time point A in the past.
What scientists found in the quantum delayed choice experiment seems to challenge our linear perception of time, suggesting that retrocausality is real. It opens an entirely new chapter in science. Most importantly, it offers a way to resolve one of the deepest mysteries in quantum physics, what Albert Einstein once called spooky action at a distance. If the future can influence the past, then particles don't need to send signals faster than light. They may already be connected across time itself. What once appeared as something strange now starts to look like a deeper layer of reality we are only beginning to understand.